Thanks, Sarah. Oh, did you catch that? Thanks, Sarah.
Yes.
I want to, and I'm really happy. Greg and I go way back. I went to school with his older sister, and he also became a secondary school teacher at our old alma mater, Hagersville Secondary School. He taught the sciences, math, phys ed, and alternative ed for 32 years. He also coordinated the alternative program called School Within a College, or SWAC. The program was for at-risk young adult students looking to complete their secondary diploma, applying to secondary education and or training, and kickstart a long-term career path. And that's kind of where Greg and I met again after so many years. I hadn't seen Greg in ages. He was working in this program. He has a wealth of knowledge in the math science area, and I'm really happy to introduce him to all of you and for him to share a little bit of his knowledge in the math area. Greg, I'll let you take over.
Thanks, Mick. Now we'll go Skanoko, greetings with respect, and I hope everyone is well. The actual translation or the real true meaning of that phrase is a little different, and I think before the end I'll go into it. But basically, it's formal greetings for people that I've never met, and happy to have you here, and happy to be sharing some of the things that we're going to be going through today. Putting my screen up right now. It says, no need to read this small print. I will share it with my voice. Basically, I'm a facilitator. I'm a storyteller. I'm a former teacher. I'm a coach. I train trainers. I do a lot of things in those type of leadership roles. So in facilitation, we have a saying, we want to be a guide on the side as opposed to a sage on the stage. And that's how I have spent my career in all the capacities of where I like to be facilitating learning as opposed to being a lecturer, sage, pontificating, although sometimes there is a need for a little bit of teaching of content or information. I apply the same concept as I mentioned here to leading, teaching, and coaching. The information I'll be presenting today is drawn from my experiences and my connections and my professional development resources that I've accumulated over several years, and the research that I may have done too when I was in university and did my master's work, and also continue to try and do through some of my other projects. Things that I found useful over my 32 years of teaching. As Mick mentioned, or Michelle mentioned, secondary school and adult learning was what I taught. I've coached for roughly 45 years. I've coached something in all different ages, and I've done 31 years of facilitating adult learning courses. So I draw on more experiential, practical experience as opposed to having spent a lot of time, even though I did, in the academic research area. I will utilize stories and practical examples using math symbols, applications, and processes, and we'll talk about those in just a few moments, just a little bit more. I will also share holistic principles that have been shared with me. Throughout my life, I've learned from the wisdom of many people of all ages, careers, and varied experiences. I've had the good fortune to travel extensively and learn from people all over Turtle Island and also the world. I've engaged and connected with many cultures and many nations. Obviously, what I share today cannot be all-encompassing, either with my experiences and or all-encompassing of math principles due to our short time together, but I will endeavor to share that which has been shared with me. So we'll get going here. One of the key things and messages that I like to always share, especially about math, is the understanding that math is a language on its own. And until people kind of look at it, they do have sometimes, I think, challenges with learning math because of the fact that it is a new language. A key for good math understanding is a solid foundation in the meaning of the symbols, terms, and variables, and eventually equations. Understanding that math as a language creates a basis for analogies to enhance understanding. Okay, there has to be relevance. That's to the learner, and that's a real key thing. So that not only do they now have to start learning the language, but they also have to start, it has to fit. A consistent question, and I'm sure some people have said that too, especially with math, is, what am I ever going to use this for? So math literacy is analogous to English literacy and proficiency. And as with English, math has an alphabet. That's the symbols we're going to be reviewing today. Math has words. You have to take those symbols sometimes and put them into words or phrases that you're going to utilize. And then also math has sentences. That's the equations that are worked with once you get into higher applications of math or simple arithmetic. Understanding their basic meaning and usage prepares learners for progressing towards greater understanding of the applications of math. Relevance. Okay, what are they going to use it for? Again, you have to keep that in the back of the mind, because then you can adapt it to their understanding or to their way of knowing. Okay, so what are these symbols that we're talking about? I'm going to start with, so in English, letters represent sounds. In math, numbers represent quantities or amounts, or simply how many. And again, having that understanding, I find, especially most recently when I was in the SMAC program, that students came in and they really didn't know what they were looking at. They didn't understand the basic alphabet of math. They didn't really know why they were using, not only why they were using it, but what it actually meant. So math is a system of counting. Okay? Knowing how much, how many, what's the quantity. And a system usually implies structure, and structure implies rules. So a rhetorical question at this point, why rules? Okay, what are the rules? Why do we need so many rules in math? Well, my click was a little bit slow there. Okay, so the reason we have rules is to try, we're constantly searching for more efficiency, so that when we're doing math problems, or trying to use math to solve some of the things that we need to solve and know, it's so that it takes less time. It's just, again, a more efficient use of our time. And second of all, we're utilizing those rules and those structures for reliability. In this case, the ability to reach solutions more often than guessing or trial and error or even luck will do for us. So again, it needs to be repeatable, not just something that you got lucky because you took a good guess. Although there are educated guesses, again, and I teach students to do that as well. So what is it being used for? And how is it being presented is probably even a more important thing in order to engage not only adult learners, but also specific personalities, especially within specific cultures. I'm getting a message here about my internet, so I'm going to flip off my video here. If I can get that to go off here. Hold on. Where's my...
Greg, it's Sarah. Are you able to see the web camera icon at the bottom of your screen?
Actually, I'm not getting that right now. I'm looking for that. Actually, here's what I'm going to do. I'm going to stop my share for a moment.
Now,
stop my video, and now I'll come back to it.
Perfect. Thank you.
Mm-hmm. There we go. All right, sorry about the jumping around here. So next, one of the things that we talk about within, and I did intend to use the word ain't. It's actually a very good book that I have used over time quite often, and it's called Telling Ain't Teaching. And in my facilitation, especially with a program called the Aboriginal Coaching Modules, which I helped develop almost 20 years ago, helping coaches, adult learners, learn how to work with Indigenous people better. And I've utilized and taken that as, and myself and a fellow master facilitator, we've taken that idea. Then when we train our facilitators, we really use this as a mantra line, that telling ain't teaching. Lecturing is not the best way for a learner to understand. Experiencing it through practical, relevant situations is probably one of the things many people have heard about and probably maybe even try and do. And so then sometimes it's just trying to add a hint here or there that will actually make it even better. One of the things that when I'm training facilitators, training leaders, training coaches, I ask them to aspire to develop real context and relatable, relevant practice. Make it as game-like if it's with a coach. Make it as applicable to what they're looking to do or what they are presently doing. Whether your role is leading or if you're supporting, I endeavor to utilize analogies to enhance understanding. So I try to tap into the knowledge they already have. And I also really look to help the learners realize that they do have a lot of knowledge. There are a lot of things that are applicable even to math, especially if they look at math as being some type of foreign thing. It's a foreign language, since we do call it is a language on itself. The colleague of mine who's a master facilitator that I mentioned, she uses this terminology that you have to learn with your eyes, that people tend to want to just learn with their ears. And then people who are leading or instructing or teaching, they also want to just use their voice rather than using visuals, using other examples, using other senses. So understand what you see as opposed to always being told what to do. So again, it's utilizing that aspect, that sense to enhance your learning, not just doing verbal stuff all the time. So, and this is Sarah, I think I went ahead too far. There we go. All right. So if you could throw in the chat, how many? Just throw in the chat. And if Sarah, if you could tell me what's coming up in the chat. How many on the left side of that equal sign?
I'm keeping an eye on it. And our first answer from David and a few others is 8.
8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Probably the earliest way to do math, counting, keeping a tally, using sticks, little slashes, that type of thing. Okay, moving on visually. How many? What are we getting now? How many?
And Tiffany's and others are saying 6.
Okay, excellent. Okay, how many? Now, what's the reason you knew that was 6, even though there are not 6 little sticks? Well, actually, I guess technically there are 6 little sticks there, but there's a progression in the complexity of how you're counting now inside of that yellow box that you can see on the screen. Just toss in the chat, what is it that's progressed here in managing and organizing your counting?
We have one response from Nancy. She says it grouped in 5 and then 1 extra.
Absolutely. Excellent. So bundles of 5. So again, we're starting to get something to say, okay, we've got something visual that is representing the amounts that we're going to be working with, or the amounts that we've counted to this point. So I'm going to go out on a limb and conclude that no one had difficulty with this or the previous example. But moving on, how many? How about now? See if we get any responses whatsoever. Does anyone have a guess as to how many? I'm anticipating that I might get one specific answer. Oh,
Michelle,
no one's stepping outside their.
Michelle has asked how many what? David has said 10. Stacy says 1,
Yeah.
and Angel says 10.
10.
And Nancy says 11.
That's probably back to guessing now, trial and error. Absolutely here. So now we've moved into something that this actually is a symbol that represents a quantity. It's actually a symbol that comes from Mayan culture, ancient Mayan culture. And so indigenous people, again, had very sophisticated counting systems. Again, one of those ways that I tell people that we weren't as primitive as we've been made out to be, whether that's people here on Turtle Island or in the Southern Americas, or even some indigenous people in other parts of the world. So this particular symbol, this face, represents the number 8. It's actually the symbol that they would use for 8. Now, they didn't necessarily use this for calculations. They would use this as, say, a house number or a building number or a structure number, so that they would see that this is building number 8, or this is to locate things. And again, within the Incan cities, they did have numbers posted on their buildings so that they could be identified and you could find people. So again, there's that aspect of especially when I'm working with Indigenous learners, is the idea that math is not necessarily a foreign thing to Indigenous people. In fact, the Mayans were one of the first people, or one of the only ancient cultures that actually had the concept of zero. And back, if you're old enough to have been around, and I'm sure people were, but I mean to be aware about the millennium, when we hit the year 2000, and there was this big debate about how many years it was. When did the millennium start? Did it start at the beginning of the 2000? Did it not go till the end of the 2000? Where did it actually start? There was arguments that it was possibly back in 1999, because of the existence of many counting systems, many cultures. They didn't have the concept of zero, nothingness, that you start at 0 and then move forward. You don't start counting at 1. And there's a lot written about the idea of, okay, how do calendars work? So you have 30 BC, 29 BC, 28 BC, you get down to 1 BC, and do you just jump to number 1 of the new Gregorian calendar? So you go from 1 BC to 1 AD. And so then with that time frame in, there's a missing concept, and it's the concept of 0. Where's our starting point? Where's our end point? And where's our concept of nothingness? So again, the Mayans actually had that concept, and they're one of only two cultures that had that in ancient times. The other was the Mesopotamians. So other examples, and you can see, I'm not sure whether you can see it clearly or not, but the top left-hand corner here has the concept of 0. So the face that's in the top left-hand corner is actually the symbol that the ancient Mayans used for the number 0. Okay. So this is a way to draw in cultural identity within math. Although in a few minutes, I'll be asking about whether there actually is culturally content material within math, or is it just the way that it's being approached? So you can keep that question in mind. So moving on, after that, this is some pretty interesting information. How many? Mayan number symbols used for quantities and calculations. They didn't just use the faces. So at this point, there are multiple numbers on here. Let's see if you can figure out the system. Moving from left to right, what numbers do you see? And I think it actually should be fairly apparent. If you could throw into the chat, give you a moment to figure that out. Anyone answer as the numbers are seeing?
I see Angel saying 19. Hang on, there's a whole bunch of responses now. Stacy says the 5 is a rectangle. Shannon says they're counting from 1 to 19. Nancy's asking, are the bars worth 5, the full bars? And Tiffany's saying 19.
Mm-hmm. Yes. From left to right, 1 to 19. And yes, the bars are 5. But what's also unique about the way that they're tracking these numbers? What do you notice is unique about the way that it's being tracked?
And Shannon's noting they're putting them on top of each other.
Mm-hmm. Mm-hmm. And so again, if you
Jaceline says, or Jaceline says, grouping in 5s.
Yes.
David's saying moving from left to right.
Mm-hmm. So the left to right representation is just the way that historians have grouped this. But you'll notice that actually that the Mayans did stack their counting on top of each other in a vertical direction rather than on the horizontal. So that's unique, but also it made it easier to work with. The Mayan counting system that you're seeing on the screen right now has actually been identified as one of the most efficient ways of doing calculations within math. in that it actually works when you learn to work with these numbers and how the way that they're represented, they're symbolized, the quantities that they're symbolizing. It was actually one of the most efficient systems to utilize. And yes, the thick bars are 5s, and so that they used a base 5, but they used it within a base of 20. Now I didn't show the 20. The 20 is actually a kind of an oval shaped disc, and then they would move on from there, so that they bundled their numbers within 20s. So it was base 20, the main base was 20, and then they had a sub base of 5. And in reality, that makes sense if you think about the fact that there weren't calculators, things like that. Anybody hazard a guess as to why, what's significant about bundles of 5 and then also base 20? Give you a moment to think about that and throw a few answers into the screen. And I'll say it one more time. What is the basis, or why do you think they used base 5 and base 20?
I think our audience is in deep thought. David saying common factors of each other. Shannon saying
Yeah.
both 5 and 20 are easy to count with. And Angel, Fike says 5 fingers on a hand, 20 in hands and toes. And Jaceline says easy to count.
Yeah. Who said fingers and toes?
Ayla.
Ayla.
And
Yay,
Angel
yeah.
is saying fingers and toes.
Yeah, absolutely. That's what it was. That, again, what was at hand to represent these symbolizations? And again, that's how people, even today, sometimes will be counting on their fingers. I don't know whether they actually pull their shoes and socks off and start using their toes, but in reality, they would definitely be using their 10. And that's actually why other number systems in the world are base 10 as well. And that's the one that we utilize as well. So spending a lot of time on this. Okay, the representation, the symbols that are representing the quantities that we want to work with. Okay, you may be much more familiar with Roman numerals, so a little bit easier that you could figure out 1, 2, 3, 4, moving from left to right across the top, and then second row on the left hand side, the V is a 5, and so on. So here's the Roman numerals 1 to 12 on the screen right now. Probably much more familiar with it than the Mayan system. But again, when you start, again, you can see that their system works horizontally rather than the vertical plane, like with the Mayan system. So one more time, how many? It'd be interesting to see what people write down. How many does that symbol represent?
So we're getting 1 and we're getting 5, and 5 is one group.
Absolutely. So it is a single symbol, yes, but that's not what it represents. 5, it's very familiar. It's interesting when I talk to students, I have talked to students, and I'll say, well, what does this represent? And they go, well, 5. Well, explain that more. 5 of what? A quantity of 5. But we know that it is, okay, what does it mean to represent? It represents a known amount, and that amount is 5 of something. If I could do another visual here, I would just put down the 5 tally ticks, something like that. A quantity of how many do we have, and we conceptualize and know how many that is. Okay, we can even visualize how many that is. Okay, so it's easy for us to work with because we start understanding what that symbolizes. The difficulty is when we start getting into not only that it's a specific or a defined amount, it's when we get into other things like this. How many? If we say X or we say an A, how many does X represent? How many does A represent? And I'll put that out there to throw an answer into the chat box. What do these symbols represent? The symbol X, what can it represent in math? The symbol A, what can it represent in math?
So several people are saying it represents unknown. And Maggie has said variables.
Absolutely. So we got them both. In math, what can or do these represent? An unknown amount. Absolutely. So we don't know it yet. But again, things like X's and A's and things when you get into algebra is very intimidating for learners. They don't understand why we're using this because it's not a number that they're familiar seeing. But again, it's understanding the language that they're now being taught to utilize. The language. What's the language? What's the symbols that mean that you're looking at? And just like the numeral 5 that everyone is familiar with, representing a quantity of 5, the previous pictures that I showed you, Roman numerals represents a quantity of 5, but it's not the same. It doesn't look the same. The mind faces didn't look the same. The series of sticks in a vertical plane and dots did not look the same. And I think students look at math a lot of times and they'll say, well, I don't understand even what I'm looking at. I don't know what it's telling me. I don't know what it means. And that's partly because, again, they didn't have a good grounding in the essential basics of what they were actually looking at. What were they learning with their eyes? Okay. And then they would just verbalize and a lot of times shut down. So I think it's a really key that if you can guide a learner to the idea that what you're seeing, you have to really understand and start to take up the idea that I have to learn what I'm looking at. Just like when I looked at the alphabet and I learned my letters, or I learned how to put words together, or I learned how to put sentences together. I have to take the same approach because it is a language. Math is taught and communicated through its own language. Okay. And then also there's so unknown amount or a variable amount. So that's kind of my first kind of really big push, and it seems very simple, and I've spent a lot of time on it already, but I think it is the key. It's the one thing that I've, through experience of all the different programming that I've been involved with, is that students don't always understand what they're seeing. So in a very quick methodology, I will go back and say, okay, let's start getting you to really understand some of these symbols that we're going to be using. Understand those first. And once you can understand those symbols in a better way, in a good way, then we can have a better shot of then starting to utilize, okay, how does that fit into a simple equation? How does that fit into algebra? How does that fit into a calculation using Pythagoras theorem? So before you start getting too complicated, they really have to be able to understand what they're looking at. Okay. Another way of saying a variable amount is an amount not yet known. And that's also something that I encourage any type of leader, support person, teacher, assistant, educational assistant, that again, you need to know your material really well, but you also need to be able to, you have to be able to adapt how you're explaining it. So instead of just saying, if they don't understand what a variable amount is, you have to be able to reframe it very quickly into their vernacular, into what's something that's relevant and that works for their understanding. So you have to be adaptable. You have to have plan A, B, C, and D that you can go to try and explain something. And I'm going to talk about other tricks that you can use, or other ideas anyway that you might utilize for doing that as we move forward today. Okay, we've been going for almost 25 minutes already. Okay, we need a movement break. Okay, not a break, nature break yet, unless that's absolutely necessary. But stand and stretch and move for 2 minutes. Even if you just go for a walk away from your screen real quick. And so from now, 2 minutes to just get up and move, stretch, and move about right now, because that's also another key that we're going to be talking about today. And I'm just going to drop my screen share for a moment. And I'm going to head back and I'll show you. Now I'm going to get up too and just kind of go and open my window here. So minute and a half to go. Move up, stretch, do stretch a little bit. If you've got time to grab a drink, something like that, stick your head out a window like I'm going to do, please do.
Are you okay, Greg?
Yeah, I'm back. I was up stretching a little bit. Yep. Michelle's asking because I've actually been working through a back injury all summer long. But also not just the reason, it's not important to move just because I've got a back injury, but also it's just sitting for a long time is just not healthy for any of us. So our online reality, I think that needs to be utilized a little bit more. And even in a classroom, it needs to be done a little bit more frequently. One of the things that I did in my SWAT classroom was that I would have students take frequent breaks of even just getting up, heading down. Our classroom was on a second floor, just walk down the steps, go outside for a few minutes if they could, and just take those breaks. Take not only a mental break, but also a physical break and get moving a little bit rather than sitting. And they were free to move about the room every once in a while, as long as they weren't interrupting other students. So yeah, good, we're back. I'm gonna go back to sharing my screen. I also like to kind of do, or not kind of, but I like to do questions as we go. So before we move on to my next section of information here, presentation, does anyone have any questions about the first segment that I went through, took you through this morning? Any questions or comments? Question or comments that have come up about what I presented for the first few minutes? And hoping we've got most people back already too.
I don't see any coming up,
Okay.
Greg.
All right, no worries. I'll move on. Part of it is the comfort zone.
Nancy said, no,
Okay.
it's been very good.
Okay, thank you. Thank you, Nancy. Now we'll go. All right, so I was beating to death understanding what you're looking at. So I'm going to take just one more, a different look at the same concept. So in math, many symbols have multiple meanings or applications, and that can be confusing for learners. So again, another reason why it's important that they really understand what it is that they're looking at. So, I would put things on a whiteboard in my classroom, and I'd say, "What do you see? What do you see?" And students would just, there were times, sometimes if they were, especially if they were frustrated, it would be the idea of, well, I don't know. I don't understand anything up there. And in reality, there were numbers, 5 plus 3a plus x squared equals whatever number. And I would say, in reality, let's back up for a second. And what does this symbol right here? So I'd be point to say the number 5. And they say, well, yeah, I know that, but I don't understand that other part. I don't understand why you do the rest of that too. So again, understanding and getting to the point where they're confident looking at and they know what they're looking at, learning with their eyes, as my colleague Dorothy would say consistently. So as you can see on the screen there, you've got a plus sign can mean addition, or it can mean a positive integer. And again, integers is a topic that really sometimes is a challenge, especially when you get into negative quantities and then also working with negative quantities. And so a negative sign or a dash can be subtraction, or it can mean a negative integer. Also, many operations can be expressed in multiple ways. And again, learners need to be familiar. Okay. Not sure of how many you would actually know. There's 1, 2, 3, 4, 5, 6 ways to show multiplication within math. Okay. 2x3, using the x signs for multiplication, probably the most common and familiar. And once you get into algebra, you have the challenge of saying, okay, is that a multiplication sign or is that a variable factor sign? One of the things that I would do with my students is I would use a script looking x when I wanted to use it as a variable, and I would use the more square x, and I would make it smaller. I would get students to write it smaller. But that's also why, because of the fact that you have that challenge of, is it a variable or is it an actual multiplication sign? That's why there's other ways to show multiplication. But once again, this is something that students need to be aware of. Learners need to be aware of. 2.3, okay, the dot meaning multiply, okay, dot product. You will see it in some textbooks. Brackets around both numbers, 2 times 3. or just 2 bracket 3 means multiply. And if the brackets has even more things inside of it, it would mean each one of the terms or each of the variables inside the brackets would need to be turned. I didn't put that down as an example. A number and a letter next to each other means multiply. Okay. And 2 letters together means that they're being multiplied together. So once again, it's being able to understand what they're seeing, understand what it is that they're looking at. Oh, that went ahead too far. And of course, with division, you've got 6 divided by 2 or 6 fraction 2, fraction bar 2. And I didn't put that on the top of each other. I left it on the same line. Okay. And there are actually other ways using exponents to actually show division. But also a key thing is understanding that a fraction actually is a division if you're actually going to carry out the operation. And that's also a way that you can convert fractions to decimals. And again, it's making or having students making sure that they've got those essential fundamentals of knowing what they're seeing, knowing the language of math. So understanding the language of math begins with understanding symbols, not only the appearance and the identification, but I go further and make sure that they really understand the conceptualization behind it. As I mentioned already, that I kind of beat the idea of what were you seeing with sticks, Mayan faces, Roman numerals, and then familiar symbols that represent numbers, the one that we're familiar with, 5s, a number 5, a number 6, a number 7, a number 210. We understand what that conceptually is supposed to mean, although sometimes we may not voice it in, our students may not voice it in the word that it's a quantity. It's how much I have. So looking at some other math symbols, plus and a positive sign, minus and a negative sign, times and a multiplication sign. So you've got an X there and you also have a dot. And as we've already mentioned, you've got the division sign plus also a fraction bar, a slash. You also have other symbols, equality, equals, inequality, approximately equal to, something that you get students to understand that they don't need an exact answer. They need something because of maybe rounding or multiple decimals that you actually should be putting down approximately equal to because you've rounded it off. Plus or minus, less than, always a challenge. I think sometimes students forget that they're just read from left to right. So that is less than because the number on the left side is of the point of the bracket, meaning smaller. And then any term or number that you would have on the right side of that symbol is in the open space, which is larger. So is less than or equal to. So again, it's being able to not only see the sign, but also interpret and understand the conceptualization. And again, taking the time, taking just a little bit of extra time and or encouraging students to take their own time, learners, and or providing them maybe with some worksheets, sometimes where all they do is just identify what they're seeing is incredibly important. The row down where pi is, you've got because. Also, that can be used as for since, if you're doing kind of an if then else type of thing. Because since this is true, therefore this is true. So since or because is the same. And then you start getting into some of the more higher learning, like the capital letter sigma for the sum of. You've got the integral sign there. You've got the Greek letters alpha, beta, that are often used to represent angles, unknown angles, congruency, those types of things. So again, there's a lot of symbols and there are a lot of resources. It's very easy. It's simple to go online, Google it, and get a number of different symbols that are used in math in nice little charts and nice little tables. And students can access them, if they've got their phone and they're allowed to use them, they can just Google it, maybe take a screenshot of it. Now they've got it in their photos so that they can refer back to it. Again, just like within, I was a physics teacher as well, that we utilized equation sheets because I wanted them to be able to utilize and use the equations. It wasn't a real big thing that they necessarily memorized them. As they utilized and used them more, they would actually become familiar and they would learn them, not just memorize them. So
again, we're hoping that they're going to learn these symbols, not just memorize them. Multiplication notation. Terminologies. Sometimes this, again, can be very confusing. Multiplier, multiplicand, and then the product or the answer. So once again, something like that, I might put that up on the board, 2 times 3 equals 6, and ask a student if they understand what they're seeing. And then I would slowly progress to a little bit more complicated sentences or equations and say, okay, do you still understand what you're looking at? Now, the thing called the commutative property of math is that, does it matter if the multiplier is first and the multiplicand is second? Or can you have the multiplicand second and the multipliers, or multiplicand first and the multiplier second? Order doesn't matter. That's the commutative property of math. And again, something that students should start recognizing. I don't necessarily get them to use the terminology multiplier and multiplicand as well. It's not as important as if when we move into division, but again, an awareness there are further applications down the road. The other term that you're seeing on the screen here, okay, is the idea of factors. Factors of 12. Well, all the factors of 12 are right there on the screen, 1, 2, 3, 4, 6, and 12. So understanding that when you have a number and you multiply it another number to have a product, so you've got a multiplier and a multiplicand, that those two numbers are considered factors of the product in the answer. So introducing that terminology again, I think is very, very key. And then you can also use it when you start getting into probably one of the most challenging areas for a lot of people, again, is fractions. And working in the SWAC program, we had a huge trades program, and being able to work with fractions is just so vital for anybody involved in any aspect of trades. And this knowledge comes in handy when you start talking about lowest common denominators. So you have to be able to factor numbers. You have to be able to get a greatest common factor or a highest common denominator, something, or a common denominator. And we'll talk a little bit more about that again. So again, terminology along with the symbols. Conceptualization. It might seem like a bit of a chore to use sometimes some of the terminologies that exist, but again, it's part of the language. Division notation, I think, is even more important than, say, multiplication notations. And on the left side, you can see three different ways to do the same thing. And you got the old school, you would do it by hand there on the second line there. You've got dividend divided by the divisor equals the quotient. Again, you could use answer instead of the quotient. But when you're doing it in the old fashioned way, if you're doing it long division, you would have your divisor. Inside your brackets, you got your dividend, and the number that you're calculating on top is your quotient again. And then at the bottom, you can just see that it's in fraction form. Again, emphasizing or making them aware of, or keeping them aware of, that the fact that a fraction is actually a division if you're actually going to carry out the actual operation. And then again, on the right side, you've got 18 divided by 3, or in long division, 3 divided into 18, or 18 still being divided by 3. This actually kind of comes up to and brings into the idea that I had a situation years ago where a student came in and said, well, which one goes into the other? Because I was taught gazintas. And I said, gazintas. And then I quickly figured out that they went goes into. So somewhere along the line, they had a teacher that simplified things for them and said it goes into. But I think utilizing that terminology was actually, for that particular student, a little bit more confusing than it was enlightening or enhancing their learning. So I would, even though you like to kind of sometimes simplify things, you can also oversimplify, where it actually created more of a challenge than it did a useful help. The gazintas, but I still remember that to this day. You know, what are the gazintas? And then a little quote at the bottom, just bit of motivation, is things are only hard until you learn them. And that's, again, a mantra that I tell the students. I said, once you know what you're looking at, I said, this other stuff that you're being asked to do, especially at an adult learning level, I took the time with my SWAC students to go back a little bit in time, make sure that they have a better grasp of what they're looking at, a comfort, a confidence with what they're looking at and seeing. And then that really helped when you had to move forward to a little higher applications of math and arithmetic. Powers and exponents. And I'm trying to hit some of the key things, especially when you're starting out with students, adult students too. Exponents are often a foreign language within the foreign language of math, and that they just are very misunderstood. And in fact, again, we get back to a terminology where a power is actually the base and the exponent, as you can see shown in the graphic on the bottom right-hand corner of my screen. So although what actually happens is that a lot of people say 5 to the power of 2, when in reality, they should be saying 5 to the exponent 2. Now, it is very common to say 5 to the power of 2. So it's not absolutely wrong, but also sometimes it can be confusing when students look into a textbook and they are not using the word power. They are using the word exponent. So again, it's just, again, basic knowledge, basic terminologies, so that when they see it, they recognize it and know what they're looking at. And there again, I've got a bullet there at the bottom, once again, talking about the idea that simple explanations are often needed for better understanding. Just keep it simple rather than get to make it too complex. But sometimes we can oversimplify, and that actually leads to lower comprehension rather than increased comprehension. So staying on this theme of what does it mean, especially with powers and exponents. Often the common explanation for how to execute a power is misinterpreted. So I've taken this from a textbook, the next line where it says, the base is multiplied by itself the number of times indicated by the exponent. So very often on the left side, this is the result. 2 times 2 times 2 times 2 times 2. So that you've got 4 multiplication signs and 5 bases being multiplied. So that would work out to, and you can see the progression moving down to an answer of 32. But 2 to the exponent 4 is not 32, okay? 2 to the exponent 4 is actually 16. And over on the right-hand side, you would see the correct version. And where the confusion comes here is the idea that there are 3 multiplications and 4 bases. And that quite often confuses students, that they're not sure. Well, but it says you have to multiply it by itself 4 times. Isn't that what that means? And so they expect to see 4 multiplication signs. So what I've done is I've changed my terminology when I'm talking about exponents. And I get them to understand that the exponent is the number of bases that they are multiplying together. And I've had far more success with students leading to the correct answer, and far more success in being able to solve the equations correctly and utilize the concept of a power more effectively by understanding that that exponent tells you how many bases you have. Now multiply them together. So just a bit of a hint of how an alternative way of explaining what powers and exponents actually mean. We've been actually talking about different operations: addition, subtraction, multiplication, division. And of course, that then leads to the memory device or mnemonic BEDMAS. In some places, actually, brackets will be parentheses, and I forget there's actually a little different memory device that goes along with it. Some of you may be more familiar with that than I, but I was always taught BEDMAS. So brackets, exponents, division, and multiplication. But the key thing about division and multiplication is in the order they appear. So again, it's not just remembering the order in the word BEDMAS, but it's also realizing that D and M are actually inverses or reciprocals of each other. They're actually pairs, and that in the order that they appear. So if a multiplication appears before division, then you would do the multiplication first. And then finally, the last grouping is addition and subtraction, and again, in the order they appear. And again, having students understand and utilizing memory devices is good. For me, it's not terrible, but sometimes I think shortcuts are given without them truly understanding the meaning of them. And I kind of I kind of relate it to a story that goes back a number of years about the concept of a little person or a little man. Actually, it was the terminology back in the Leslie political correct times, but it was the little man in a Coke machine. Little man in the Coke machine was, how does a Coke machine work? Well, when I go up and I put my money in and I press the number for the button for the product that I want, the pop that I want, there's a little man sitting inside. He collects the money, sees the light, and runs and grabs the pop, the can or the bottle, and throws it down the chute. So that's how a pop machine works, or a vending machine works. It's a little man in the Coke machine, a little person in the Coke machine. And, sure, that makes for a great story. It's an oversimplification about how it works. It's far from reality, but sometimes we might use shortcuts and simplification stories that are misleading. So again, just something to be mindful of, but again, it's not a must do or happens all the time. Actual visual representations of the application of bed mass. And again, putting up an equation like the one at the top here, 2 plus bracket, 7 plus 3 bracket. Okay, that asterisk is a dot product, so multiplied. 3 to the exponent 2 or 3 squared, another way to talk about it. Again, we've talked about multiple ways of multiple meanings, but we can also have multiple ways of verbalizing what we're seeing. Plus 4 times bracket 3 minus 1 and another bracket plus 10. So how do we do this? So solve within parentheses first. So the 7 plus 3 becomes 10. The 3 minus 1 becomes 2. Then compute the exponent. So go to the 3 squared, make that 9. Perform multiplication and division in the order that they come. So you've got the 10 times 9, 2 plus 90, plus 8, plus 10. And I'm sure all of you are wizards at doing this and already had the answer of 110. So once again, I'm going back to this theme that I'm beating to death. It's the idea of students, learners need to understand what they're seeing. They need to know and understand the language of math, because if they don't, then again, an equation like this, an algebraic equation or some type of number equation, is just going to look like complete Mayan symbols that they have no idea what they mean. Once again, I'll just have you stay on the screen. Oh, no, I am saying a nature break. Okay, so let's go with, how far along are we here with my time? What did we get to? 48 minutes. We've been another 50 minutes. We've been 45, almost 50 minutes right from the very beginning. So let's do a quick another stand, run off, snack. So a little longer. Let's be back in 5 minutes. Let's be back in 5 minutes. I've got 10:53. If everyone could be back a minute before 11, that would be awesome. Okay, one more stretch break, one more stand break, maybe get a drink. And also what I just mentioned. Be back in 5.
Thanks, Greg, and everyone. I'll just pause the recording. I'll ask Michelle and everyone at ONLC to make sure to remind me to start it again after the break. Thank you.
Thanks, Sarah.
All right, we're underway. Thank you.
Awesome. I'm going to stop my video just to help with the feed. Get back to sharing my screen. And there we are. All right. So, fraction notation. Once again, same theme. The explanation of each part of fraction is about more than just the labels, though. So knowing that the numerator is on top and the denominator is on the bottom, as you can see, you've got explanations and brackets underneath. Denominator is the total parts in whole. And if anybody has ideas that they could share, either a quick note in the chat, or maybe we go to voices unmuting near the end, the idea of even the concept of a whole, one whole thing, one full thing sometimes, searching for getting students to understand that, because in some cases, often students also are a little bit shaky on the concept of what do you mean by a whole? So again, if you've got something, I'd love to hear it. And then you've got a whole thing that's
divided into parts or has sections to it, equal sections. And then, so then how many of those sections do we have? And obviously, I'm sure all of you are familiar with the idea that there are visuals that are out there. In my classroom, even at SWAC, I had pie charts, pizza parts, pizza slices, visuals of egg cartons. I even brought in egg cartons so that they can actually see a practical concrete thing in front of them. And again, anything that you can use for visual support, but especially with adults, one of the things that I find the most useful is to utilize money, and especially in the absence of other visuals. And also, if I've actually got the physical coins, to pull them out and show them, or even bills, pull them out. And but also, it's just the idea that to say that, hey, if we're going to make $1 and you've got only quarters, how many quarters do you need? Well, I need 4. So if you've only got 2 quarters, how much of $1 do you have? Well, I got a half $1. So again, money tends to be very useful. And I also find that utilizing money is very useful. The concept of different value parts of money for unit conversion, the idea of units. So that if I've got 20 nickels, that makes $1. But then also that $1 is a larger unit than nickels. So when I'm converting from a smaller unit to a larger unit, I'm going to end up with a lower or a smaller number. And then vice versa. If I were going to break up $1 into nickels, I would go from $1, a quantity of 1, to 20, because I'm moving towards a smaller unit. And again, just a way of helping them to conceptualize what actually is going on when I'm converting units from a smaller unit to a large, or a larger, breaking it up down into smaller units. What can I expect? What's my educated guess going to be? And then also I can kind of check my calculations, because if it doesn't seem to make sense, if I'm converting $1 into nickels and I come up with half a nickel, that doesn't make a whole lot of sense if I'm doing my calculations correctly. So it's a way of self-checking themselves. And again, it just speaks to being a check for understanding. So my hint here is the idea that I will use money, especially with adult learners, to help them understand, visualize, or conceptualize fractions. Again, terminology, we're back to that. There's terminologies for different types of fractions, and you can see them here on the screen: proper fractions, improper fractions, mixed numbers, by definition on the left, and some examples, and or more of a visual thing for a proper fraction, the improper fraction, and mixed fractions. And I'm sure you're familiar with all of those, but once again, I just wanted to make sure I put them up to say, look, there's some terminologies again. Now we're taking those symbols and we're combining them with word terminologies. And also then we have to be able to really understand what the conceptualization is for those terminologies. One that is used in higher math more than in more simple arithmetic-like computations, though, but it's also a key thing to know, especially with orders of operation, is reciprocal and inverse. Basically the same, they amount to the same thing, even though they are 2 different terms. You can see on the left-hand side, if you take the whole number 6, and even if you didn't have it as a fraction 6/1, if you took 6, the reciprocal of that is 1/6. So you're reversing it, you're flipping it. So if you go to actually, and I do this quite often, again, I talk about analogies. I try to work from knowledge that they already know, so that now they can frame it and compare it and maybe understand it a little better. It's that inverse, the general definition, not even related to math, of the term or the word inverse is opposite or contrary in position, or contrary in direction, or contrary in order, or opposite in position, opposite in direction, or opposite in order. So reversed or inverted is also words that are used for inverse. So utilizing those types of, okay, what does it mean just in general English? And maybe they know, and then taking that concept and then, okay, so now then how do we use that terminology in math? So what is an inverse in math? Examples are illustrated above. You've got things in the center box there. You've got 14. The inverse is 1/14. Minus 32 is 1/32. minus 32 or negative 32. P is 1 over P, and so on. And then over on the right-hand side, you can see that if you've got a full fraction, 4 over 3, you can reverse it and it becomes 3 over 4 or 3/4. So again, those are the practical visual applications. So examples are above, okay, and then they're applied to inverse operations, pairs of mathematical manipulations in which one operation undoes the action of the other. So if you multiply then divide, you're going to come back with the same answer. So it's the reciprocal process. And that's where probably the term reciprocal comes in as opposed to the inverse. And also you pair up some of these operations, addition and subtraction, multiplication, division. Again, multiplication is the reciprocal of division or the inverse of division. And also at the very bottom, you've got squares and square roots, or you've got roots and whatever the nth number root is that they may have if we moved beyond the idea of x squared into, say, an x to the exponent 3 or x cubed. Adding fractions with the same denominator. Once again, familiar, I'm sure, with everyone on the call right now. You can try and do it visually so that you can see the pies, or you can just do it with a way that, okay, let's take a common denominator, and then all we have to do is add all the numerators. But I would really encourage the visuals, encourage the learning as a visual as well as the verbal. And then we've got, okay, that answer then will be 25 over 8. Okay, that's, and if you're, I'm going to flip backwards here for a second. If we go back to our fractions, what kind of fraction is that? And again, if the learner can identify that that's an improper fraction, now they're not as intimidated. But it does create a challenge again now, that what does 25 over 8 mean? And again, that's where you can draw in the visuals and say, okay, if I've got a box that holds 8 golf balls for as an example, but I've actually got 25 golf balls, how many boxes of golf balls would I have? And would I have complete ones, or would I have one that is partially filled? You know, again, just ways of asking the question, checking for understanding, and not just always checking the same way, I guess, is my message here. Adding fractions without common denominators. So then we get into the idea of finding a common denominator, and that's where the terminology of factors comes in that I had mentioned earlier in the presentation. Multiply the denominators together, convert each fraction to equivalent fraction with the new denominator. Now at this point, even though we talked about an equivalent sign, again, that might be new terminology. You may have to spend time on making sure that they really understand the idea of equivalent fractions. And actually, obviously, that is a teaching point of when you're dealing with fractions. So I'm not going to spend going through that necessarily in much detail. But now also, I'm going to get some responses here. What does this particular slide, how do you feel about this particular slide? What are you seeing? How does it make you feel? And if Sarah, you could read out when we get some responses into the chat box. This particular slide, what's the visual feel like, look like for you? How does it make you feel?
Jamie saying lacking guidance. Nancy says it's too busy. Jaisleen says there's a lot on it. Stacy says colorful and feels a bit overwhelming. And Maggie agrees about the overwhelming. Tiffany says stressed. Emily says it's busy, and Angel agrees on that.
Exactly. And so I did create this slide for that very purpose, is just to kind of remind ourselves that when we're doing and working with learners, that even though we can be very well-intentioned and trying to give them as much information and as much content, as much learning as possible, we can overdo it. And no amount of color, no amount of great organization and flowery presentation is going to be beneficial. That they're going to feel overwhelmed, information overload when they're looking at these things.
So again, I have always tried to try and keep examples very simple. I try not to clutter, like in this example, in this case. I don't want to have too much information, especially if they are really struggling with specific concepts, even to the point of, and with today's technology, you can do this. You can put up one, make it disappear, go on to a next one with just a clean board on a smart board, and then make that disappear or move it. But then you can still draw it back when you need to refer to it. So again, just all the things that were just mentioned. Again, one of those things to avoid. Division of fractions. To divide fractions, multiply the inverse of the divisor. And that's a very common statement that you'd see in a textbook or even a workbook. So once again, if students don't know their terminology, if learners don't know their terminology, they're lost. They're not going to know what they're being directed or guided or taught to do if they're not familiar with their terminology. So, and again, with adult learners, taking the time, and sometimes it seems like it's not, you're not getting the curriculum covered, by going back to ensure that the essential language is understood. And so again, I've got the examples, but when you're looking at this too, and this will be very common when you see solutions in books, they won't show the work that was done to arrive at that answer. So if we look at the first example here, 1/5 divided by 2/3. And on the right-hand side, we've got the answer. The answer is 3/10 or 3/10, but they're not showing how they got there. So to divide fractions, multiply the inverse of the divisor. So in reality, if you're going to show all your work, it would actually be 1/5 times 3/2 now. You would flip the 2/3 and make it an improper fraction of 3/2, and you would multiply. And multiplying then is a much easier process than division. And in some ways, a lot of students find multiplying fractions obviously a lot easier than even adding fractions, especially since if you have to find a common denominator. But again, that information is missing a lot of times in answers. And again, just being aware of that sometimes, especially for the students who want to jump back to the back of the book and take a look at the answers before even attempting. But it's sometimes that's a good thing, but also they only know the answers. It's almost like going back to the little man in the Coke machine again too. They understand the output, but they don't understand what went on inside or how we arrived there. And that actually is an issue, and I'm going to talk to that a little bit later, is the idea of how often do you have to show all your work? Okay. I'm not going to do this movement break because we're starting to get short on time at this point. I wasn't sure how long my slides were going to take. Any comments on previous slides here? Any questions at this point? Any thoughts or points of clarification that are needed to this point in today's presentation?
Greg, it's Sarah. I'm not seeing any questions at this time.
Okay, and I'll move on. So here's something that I posed earlier. And if you can just, well, I guess you don't see my screen right now too. I have to stretch a little bit. Is the content of math cultural? Key question. I've seen a lot of resources developed by different organizations, different places. Actually, one that I found very, very useful and helpful was done by the Ontario Secondary Teachers Federation, OSSTF, Ontario Secondary School Teachers Federation, the one that I belonged to when I was teaching. And they created, in conjunction with Indigenous learners, they did all the curriculums or all of the main subject areas, and they did it utilizing a medicine wheel concept, in which they then had lessons for each of the topics that they were trying to teach, or that not trying, but they were teaching. And they used a medicine wheel concept and said, okay, so in the physical realm, how would we approach this concept? Let's say a historical one, and something in history. And then what would be the mental way of approaching it? What would be the emotional way of approaching it? What would be the spiritual way of approaching this aspect of history that they were trying to teach? And it was a very effective way to come at it from a different way. And it also kind of speaks to probably the way that probably the top country in the world for education, the highest rated country in the world. And so I'll put that out there. Do you know what country is the highest rated educational country in the world for the way that they approach any type of teaching and education? What country is considered the top country in the world? Do we have anything coming in, Sarah? Anybody hazarding a guess?
China is coming up from Nancy and Jaceline.
Okay, probably for math, they may be, but they're not considered the top. And this particular country is actually, if you take, like, say, the top 20 countries in the world, put them together, they still wouldn't add up to the scores that this particular country gets. It's
And
a
Denise,
European country.
Sorry for interrupting you, Greg. Denise has
No worries.
mentioned Sweden. Nancy's suggesting Iran or Russia.
Okay. Well, Sweden is close. It's their neighbor, Finland. Finland is considered the foremost country for education in the world, at the elementary, secondary level, and even at the university level. Not quite as much as a few other countries, but definitely for their elementary, secondary level approaches to education. They're a country that changed to non-subject specific education, in that they do their teaching within a more practical, holistic way. They don't break it up into subject matter, but they will break off and specifically do assignments that are, let's say, they do an assignment and there is a historical component to it. There's then also an English component to it. There's a historical or something, a geographical component to it. And so then they can do all those parts, or they may ask students to do certain tasks and assignments and make sure that they're including a geographical component, a historical component. And so that it's more of a holistic type of thing. And so again, that country is Finland, and there are a number of good resources where they talk about, there's one, I'm just looking for it right now. There's a book called Teach Like Finland. And it does talk to some of the ways that they do things, but it's also a gentleman who's from the United States that spent some time in Finland. But I also find that he looks at it and say, well, we kind of do that. But anyway, just a little off the cuff thought process that ran through my head. Not sure whether you've seen a TV commercial where they actually show, I believe it's a Chinese student and then a Japanese student showing how they do multiplication by hand, and they show it on the screen. And so the way that certain cultures approach math can definitely be cultural. So the Japanese multiplication by hand method, and even if you Googleize it, Japanese multiplication, you can see either videos or page explanations of how the Japanese do their calculations of math, especially multiplication by hand. And then also the symbology of math can be cultural, and we've already gone through some of that with the Mayan numerals, Roman numerals, those types of things. But is more important, I think, than the content itself. There really isn't, I wouldn't say that there's actually Japanese actual math. There are Japanese methods. So that's the pedagogy. How do they explain the math? And then what are the processes that they teach? What's the methodology? What's the way that they teach the concepts of math? So there isn't a French math and, let's say, a Spanish math, and there isn't an American math and a Canadian math, even just like Canadian in American English with the spellings of words. So, but what there is that you can make it culturally relevant as to the way it's being taught, the way that it's being presented, the way that you have set expectations within their way that they are going to learn. The idea of you set expectations for yourself, and that I'm not going to just deliver this information in one way. I'm going to be prepared to do it in several ways. And again, that's a concept that's been used for several years with the idea of knowing what type of learner you're dealing with. And then if we speak to that, especially if we talk about Indigenous people, more experiential, more hands-on. But also Indigenous people are very much like any other culture in that they will have a diversity of, but the predominant one is hands-on and heavy within the manipulative experiential, as opposed to maybe just listening. And also, again, the visual of watching is very prominent in Indigenous communities. And finally, there are examples of perceived cultural symbols being used to help explain math concepts. Something like saying, okay, if we've got 8 poles that help make one TP, create and build a TP, if I have 3 TPs, how many poles do I need? Or if a herd of buffalo crosses the river, half of the herd or a quarter of the herd crosses a river every 15 minutes, how long will it take the entire herd to cross the river? So again, it's not that those usage of cultural symbols to utilize in examples is not effective, but again, it's just being aware that whether it's actually the best way and something they can relate to. Something that I found in a project that I'm working on in Nunavut is if you mention the word trees and try to do analogies to, like, say, the roots of a tree or something like that, it is something that they don't really relate to. Because if you're in Nunavut, you're above tree line, you're into the rocky tundra where there are absolutely no trees and no plant life. Now, they will be familiar with trees because of the internet, because of TV, satellite TV. They will be, but also, again, sometimes you will get feedback from them and they'll say, well, I've never really seen a tree for real. I've only seen pictures, because they just don't exist in their environment. So again, another way of trying to make it a little bit more culturally relevant by using cultural symbols that they're familiar with. And sometimes what I'd like to do is to challenge them to come up with their own culturally relevant symbols. And then now you know that you're not being offensive if you're utilizing, like, say, teepees, or assuming that all Indigenous people hunted buffalo, when in reality, again, the Nunavut people probably didn't do a whole lot of hunting of buffalo. Utilizing relevant analogies, basically, I just talked about it. Some experiential teaching points: connect with learners and get to know their styles, then work with them where they're at. Having moved into the corporate world a little bit more than just the teaching world, I cringe quite often when I hear, well, they're just not ready yet. We have to do a needs assessment analysis, and we need to know whether they're ready to even do what we want to do with them. If, as a teacher, as an educator, even as a coach, if I said, oh, I'm sorry, you're just not ready, I'm going to ask you to leave my classroom now, that's just not such a foreign concept. Not something that is going to be done. You have to be prepared to get to know them, know some of their nuances, know the way that they're seeing and their ways of understanding and knowing, and then work with them where they're at. Education has often and continues to use pedagogy that imposes ways of understanding rather than enhancing and trying to work with the one that they have. So again, different perspectives, then trying to work with that rather than saying, no, you need to use this way of understanding or this way of knowing. Understand a learner's reasoning skills. Are they intuitive? Are they deductive? Just how do they work? I would consistently work with my students and say, explain to me how you solve that. And, whether you do it visually, verbally, combination of both, I really want to know, because again, I would have students that wouldn't necessarily use the methods that were being shown in a book, or maybe even the methods that I was showing them. They could come up with answers, and sometimes it was intuitive, it was experience, some of it was trial and error. But again, it's being able to get them to say, okay, this is a valid way to do things, but let's maybe add a few skills to your toolbox rather than just the one way that you do it now. And that moves on to some continued pointers here. Avoid replacing or labeling intuitive skills as incorrect or wrong. If I saw a student that was only using trial and error or guessing, I wouldn't tell them that was completely wrong or incorrect. I would just say, well, let's get you to try this, because if you've got more skills, now you've got more ways to attack problems and solutions and try and get solutions. And, eventually what will happen is that once they start learning that again, and you go back to the phrase that I had said, that things are only hard until you learn how to do them. I utilize the concept of I'm going to add skills as opposed to subtracting skills and tell you not to use the thinking that you were using. And also, I also utilize this concept of more tools in the toolbox. Eventually, they will automatically utilize the skills that work best. So hopefully that is a little more structured process, or even just a process, not necessarily a more structured one, but a process, as opposed to just guessing and also utilizing trial and error. So this approach of telling them what you want them to do as opposed to what you don't want them to do, or saying that a methodology is wrong, this approach enhances a leader's understanding of the learner's thinking. And as I mentioned, one of my points on my previous screen was the idea of getting to know your learners. And it can serve to increase engagement because you're listening to their voice. I had a student who in my SWAC program who said, a teacher never asked me what I was actually thinking ever before. And that's, a little disappointing that somewhere along the line, a colleague had taken that approach. And in reality, it may be just the perception that the student had of what was being asked and asked of them. But it definitely, even if it's even if it's not actually literally happening, if it's perceived, then it's still something where they like to share their voice. Although there will be students who like to share their voices, and there'll be some that may be a little bit more shy. A good way versus the right way. In many Indigenous languages, originally we did not have a translation for the word right. They've been created just like there's been words created for TV and a number of different things. But in all my travels, in all my connections through Turtle Island, the Americas, I've been fortunate enough to travel to 44 countries, as well as every province and territory numerous times, and also all but 3 states in the US. And engaging with Indigenous people within those areas, it's pretty common that they did not have a true word for right. It's a good way, good mind, good heart, good path. Learning environment strategies. Take regular brain breaks. I'm not going to go through the SWAC story. I think I already mentioned it, that I encourage lots of it. Avoid long periods of sitting, even online, like we did today, where we got up and did some breaks and stretching and movement. Neurological research has identified human brains function optimally when moving. So that actually we had to think on our feet when we were trying to run down dinner back in the day. And health and wellness research has long identified sitting as a major factor in a number of diseases that are increasing exponentially in our tech-dominated world. Movement breaks are needed today. Something that I talked about with that screen that was so cluttered, less is more. Keep it simple. Often textbooks or workbooks provide an overload of practice questions. Experiment with how many practice questions is optimal. Again, not saying that one size fits all for every student, because how many practices they need is very individualistic. And then the concept of showing your work. What's the rationale for showing all your work? Well, teachers of mine, when I went through education, was, well, we need to know you're not cheating. We need to know how you got the answer. In the age of calculators, we need to know that you actually knew how to get it, not just having the computer or the calculator do it for you. Well, but they also have to know how to learn to use the calculator. But showing your work, my take on that has been, if it's too many questions or some of the key questions, show me all your work. If you're not getting the correct answer, then you need to be able to show me your work. But especially if there's a lot of practice questions that maybe you've given them, maybe ask for showing their work on a few key ones, maybe one in every row. The other ones you can just put down your answers. That was the way that I approached, do I have to show all my work all the time? And I said, well, if I ask for it, you have to be able to show me. And if you can, then I probably won't ask for it again. But if you can't, then I'm probably going to ask you to write out some of that. And then also you talk into the idea of marks, and you can say, in my marking scheme, if you show me your work, I can give you partial credit rather than just a wrong and no marks whatsoever. So again, there's a number of different approaches, but again, it is something to consider. Lesson planning pointers. We've already again talked about this. Know each learner as a person and also holistically. Know them more than just as a math student, knowing a little bit about how they think. Concrete, abstract thinkers, making it real for either type of thinker. Multiple plans. And when I was in teachers college, I remember them talking about having multiple plans. And sometimes it may feel like a daunting task, especially if it's a new thing that you're teaching or supporting. But again, being able to know your material as well as you're asking students to, and then being able to go to a plan A, a plan B, and even asking students to help them try and come up with a different plan can also be effective. Linear cookbook approaches versus lateral outside the box approaches. Again, my take on that is it repeatable? So some people do, some students do need that linear cookbook, but I do try to move them into more lateral outside the box ways of thinking and not just being linear with their processes. When are we ever going to use this? I posed that question at the outset of my presentation today. Learners are often content focused or even mark focused. Just find ways to celebrate the process. Adding skills to their toolbox is one way, rather than saying you have to know how to learn how to do it this way. No, once you learn this, you're going to be a stronger student. When my coaching, I tell my players, you're going to be a stronger player to play against, a harder player to play against. If we can add a few skills to do the same thing. Celebrating their learning. Even with adult learners, I've utilized using stickers or small rewards. You'd be surprised how often that actually is effective. Just some type of little sticker or little trinket for celebrating their learning. And I've mentioned this already as well. Maybe get students to help give their thoughts and or partner up or buddy up, so that learners often can share knowledge and analogies and examples better than teachers or leaders. What's the reason? Well, I think at the end, it's just speaking their terminology, their perceptions, being in their head a little more, just because they might be closer to their age in some cases. But with adult learners, it also might be, again, cultural, getting people from the same culture together. I delivered an Aboriginal coaching modules in Mistissini, which is in northern Quebec. And we were doing stuff, and most of our course was in English, but we did get to a couple of exercises where all of a sudden a couple of people put their hand up and said, hey, can I speak in Cree? It's just a whole lot easier if I speak in Cree. And I said, yeah, whatever is the best for you. I'm not going to tell you have to do this course in English alone. Some other pointers: encourage learners to be and move them towards being comfortable with being uncomfortable, a little bit outside their comfort zone in order to learn. Life is cyclic. The only constant is change. So adapting to challenge as opposed to avoiding them is something that is an important life skill that is utilized within math and can be actually enhanced in math. Learners that are discouraged by mistakes, possibly related to reactions from leaders in their life. I had a SWAC student who one day came in crying and saying that when she went home, saying that she had done really, really well on a test, that her father had said to her, well, you cheated. You've never really had good marks. You probably cheated. And she came back and she says, I hate him. I hate him. He's never given me credit. He's never praised me ever. Now that's the dynamic too, that also speaks to other cultural things going on right now. But also it's just the idea that even as a teacher, I had to progress myself and how I reacted to when students were struggling and when they were making mistakes, and being, again, utilizing some of the other pointers that I've already mentioned. Plan with your learners. And in order to plan, a lot of times you should debrief. When you've taught them something, when you have them learning something, ask them what went well in that learning. What would they like to improve? I do this with my teams. I do this with my students, so that I get their voice in helping to plan the next steps and trying to help them understand things better. So that debriefing, I debrief myself as well. What went well with that lesson? What didn't go so well? What do I need to change? Again, it's that self-analysis as a leader, teacher, instructor, facilitator. Offering up choices, alternate ways of demonstrating learning. I had students doing in math projects where they actually had to develop something or create something, and then I evaluated their ability to measure or make something with precision, especially again within the trades realm. Again, if that suited their way and method of learning, then I utilized it. I already mentioned this one: have a plan, A, B, and C. But also be prepared to change gears, not stick with one only and say, I'm going to make this work no matter what. Be ready to say, okay, hey, this didn't work. We're going to stop right here and move on to something else, or we're going to try this next way of trying to get you to understand this. And a lot of times I would make sure that I put a break in between that, let their brain reset, take a break, and then come back and say, okay, let's try this way of explaining this to you, as opposed to sticking with the one that you absolutely want it to make work. So summary of key ideas: teach the essentials for understanding, not just memorization, make it real. Coach more, plan with the learner focus. They must feel it is relevant to them. Being a facilitator versus an instructor, remember telling a teaching. Be a guide on the side versus a sage on the stage. A good way versus the right way, multiple tools in the toolbox. Persevere. Leaders, model the skill of reframing challenges and adaptability. Learners will learn more than just math. That's that holistic approach that I talked about before. And I did just notice that we're just a few moments over time. Not sure whether we do have time for any questions, queries, or comments, but there's my information. If you would like to reach out and contact me, please feel free to do so. If you're looking to call me on my cell, you may not reach me, but I'll get back to you if you leave a message or even texting, because that is my cell. So, Nyawagoa, thank you for listening, and also thank you sharing when I asked you to throw stuff into the box. And I'll just leave that up just for another moment. Is there anything in the chat box there, Sarah? Oh, looks like I took it down already.
Lots of folks sending their comments. Great presentation, says David. And lots of thanks from everyone that's really enjoyed the presentation. And I'm sure Michelle probably wants to echo that.
That was wonderful, Greg. Sorry, I couldn't find my unmute button, and my mute button wasn't muted when I was talking, or earlier I forgot to mute it. So we put together, and this is the first time I've ever done a Google survey. So I posted it in the chat if everyone would fill the survey out. It's a form of evaluation for Greg's presentation. Greg, I thought it was wonderful. I learned lots. And I know that everybody else probably did as well. You're a wealth of knowledge, not just in math, but in coaching and everything else. So thank you so much.
You're very welcome, and thank you for the kind words, Mick. But it's sharing things that have been shared with me, but also again, it's just, I'm always encouraged. Like I tell my students or learners and my athletes, I said, they inspire me. And the fact that people took the time to come and listen and view my presentation and listen to my presentation, it inspires me as well. So thank you very much for being here today, everyone.
The next presentation is on October 22nd at 10 a.m. and we have Paul Armstrong presenting. He's saying his presentation is called Assisting in Overcoming Anxiety for Adult Learners. And the third one is on November 5th, time change. It'll be at 3 p.m. because she's still teaching, and so she has to wait till after she's done teaching, so it'll be at 3 o'clock. So once again, thank you everyone, and hopefully you'll fill out the survey. Thanks, Sarah.
Okay.
My pleasure.
Now we'll go with Sarah.
Thank you, Greg. Wonderful presentation. I'm going to stop the recording and wish you all a safe and healthy weekend. Bye for now.
Want to go ahead?